Ice Apocalypse is the title of a new article written by meteorologist Eric Holthaus, contributing writer at Grist, published November 21, 2017. The basic premise: rapid collapse of Antarctic glaciers will flood coastal cities. Holthaus begins, in a remote region of Antarctica known as Pine Island Bay, 2,500 miles from the tip of South America, two glaciers hold human civilization hostage. Stretching across a frozen plain more than 150 miles long, these glaciers, named Pine Island and Thwaites, have marched steadily for millennia toward the Amundsen Sea, part of the vast Southern Ocean. Further inland, the glaciers widen into a 2-mile thick reserve of ice covering an area the size of Texas. There's no doubt this ice will melt as the world warms. The vital question is when. The article then notes how Thwaites has been dubbed the Doomsday Glacier, and together with Pine Island Glacier, both could contribute 11 feet of sea level rise. Multiple meters difference in sea level height will OFC make a profound impact on every coastal city in the world. Hence, the question about how fast these glaciers will collapse is one of the most important scientific questions. The bad news, Holthaus asks? There's growing evidence that the Pine Island Bay glaciers collapsed rapidly 11,000 years ago, when global temperatures were similar to today, flooding the world's coastlines, partially the result of something called marine ice cliff instability. The ocean floor gets deeper toward the center of this part of Antarctica, so each new iceberg that breaks away exposes taller cliffs. Ice gets so heavy that these taller cliffs can't support their own weight. Once they start to crumble, the destruction would be unstoppable. In the past few years, scientists have identified marine ice cliff instability as a feedback loop that could kickstart the disintegration of the entire West Antarctic ice sheet this century, much more quickly than previously thought. A wholesale collapse of Pine Island and Thwaites could set off a catastrophe. Giant icebergs would stream away from Antarctica like a parade of frozen soldiers. All over the world, high tides would creep higher, slowly burying every shoreline on the planet, flooding coastal cities and creating hundreds of millions of climate refugees. All this could play out in a mere 20 to 50 years, much too quickly for humanity to adapt. With marine ice cliff instability, sea level rise for the next century is potentially much larger than we thought it might be 5 or 10 years ago, Pointer says. Newfound concern is driven by the research of climatologists Rob DeCanto at the University of Massachusetts Amherst and David Pollard at Penn State University. A study they published last year was the first to incorporate the latest understanding of marine ice cliff instability into a continent-scale model of Antarctica. Their results drove estimates for how high the seas could rise this century sharply higher. Antarctic model raises prospect of unstoppable ice collapse, read the headline in Nature, a publication not known for hyperbole. Instead of a 3-foot increase in ocean levels by the end of the century, 6 feet was more likely, according to DeCanto and Pollard's findings. But if carbon emissions continue to track on something resembling a worst-case scenario, the full 11 feet of ice locked in West Antarctica might be freed up. At 11 feet, land inhabited by hundreds of millions of people worldwide would be underwater. South Florida would be largely uninhabitable. Floods on the scale of Hurricane Sandy would strike twice a month in New York and New Jersey, as the tug of the moon alone would be enough to send tidewaters into homes. Around 3 million years ago, when global temperatures were about as warm as they're expected to be later this century, oceans were dozens of feet higher than today. Previous models suggested that it would take hundreds or thousands of years for sea level rise of that magnitude to occur. But once they accounted for marine ice cliff instability, DeCanto and Pollard's model pointed towards a catastrophe if the world maintains a business-as-usual path, meaning we don't dramatically reduce emissions. Rapid cuts in greenhouse gases, however, showed Antarctica remaining almost completely intact for hundreds of years. In a new study out last month in the journal Nature, a team of scientists from Cambridge in Sweden point to evidence from thousands of scratches left by ancient icebergs on the ocean floor, indicating that Pine Island's glaciers shattered in a relatively short amount of time at the end of the last ice age. The only place in the world where you can see ice cliff instability in action today is at Jakobshavn Glacier in Greenland, in one of the fastest collapsing glaciers in the world. DeCanto says that to construct their model, they took the collapse rate of Jakobshavn, cut it in half to be extra conservative, then applied it to Thwaites and Pine Island. Right now, there is a floating ice shelf protecting the two glaciers, helping to hold back flow of ice. But recent examples from other regions, like the rapidly collapsing Larsen B ice shelf on the Antarctic peninsula, show that once ice shelves break apart as a result of warming, their parent glaciers start to flow faster, an effect that can weaken the stability of ice further inland too. If you remove the ice shelf, there's a potential that not just ice cliff instabilities will start occurring, but a process called marine ice sheet instabilities, says Matthew Wise, a polar scientist at the University of Cambridge. This signals the possible rapid destabilization of the entire West Antarctic ice sheet in this century. Once the stresses exceed the strength of the ice, Wise says, it just falls off. On our current course, other glaciers around Antarctica will be similarly vulnerable. And then there's Greenland, which could contribute as much as 20 feet of sea level rise. Next to a meteor strike, rapid sea level rise from collapsing ice cliffs is one of the quickest ways our world can remake itself. This is about as fast as climate change gets.
We passed the point of no return, and at this point, we'll say it's just a matter of time before these glaciers completely disappear to sea. We've focused more on this particular sector of West Antarctica because this is where we see the most dynamic changes. But we've been observing changes in speed, the acceleration of these glaciers, thinning of these glaciers, and also their retreat inland, which is kind of a feedback that will maintain that retreat and that thinning and that acceleration for many years to come. We've been looking at 40 years of changes in velocity over that whole sector. And what we see is a continuous increase in discharge of ice from the glacier to the ocean. In most cases, when you look at ice sheets, the important stuff is taking place at the bottom that you can't see. So the grounding line is the place where the glacier detaches from the bed and becomes afloat with the ocean. And as it becomes afloat in the ocean, we see the retreat of the grounding line on the glacier as is being melted more strongly by the ocean. And you see that the bed of the glacier slopes inland. It never gets away from the water. The water keeps following the glacier because it gets deeper inland. The first time we could image it was in 1992, and in 2011 we looked at the data and went, wow, there's been so much change in the position of this grounding line. You can't miss it. So there's a bunch of feedbacks that makes this retreat unstoppable unless suddenly the glacier starts retreating in a bed that rises up, right? But we don't see that in any of these glaciers. This system is evolving very fast and is progressing exactly as what you expect if it was about to collapse to sea. They're retreating at rates of about 1 kilometer per year. If these glaciers were sustaining this rate of retreat, they would disappear completely in a couple of centuries.
Climate change researchers have kept a wary eye on one place perhaps more than any other, the West Antarctic ice sheet, and particularly the fastest melting part of it, the glaciers that flow into the Amundsen Sea. In that region, 6 glaciers hang in precarious balance, partially supported by land and partially floating in waters just offshore. There's enough water frozen in the ice sheet that feeds these icy giants to raise global sea levels by 4 feet, if they were to melt. That's troubling because the glaciers are melting. Moreover, a new study finds that their decline appears to be irreversible. We've passed the point of no return, says Eric Rignot, a glaciologist working jointly at NASA's Jet Propulsion Laboratory and the University of California, Irvine. Rignot and colleagues have used 19 years of satellite radar data to map the fast-melting glaciers. In their paper, which has been accepted for publication in Geophysical Research Letters, they conclude that this sector of West Antarctica is undergoing a marine ice sheet instability that will significantly contribute to sea level rise in the centuries ahead. A key concept in the Rignot study is the grounding line, the dividing line between land and water underneath the glacier. Because virtually all melting occurs where the glacier's undersides touch the ocean, pinpointing the grounding line is crucial for estimating melt rates. The problem is, grounding lines are buried under thousands of feet of glacial ice. It's challenging for a human observer to figure out where they are, Rignot explains. There's nothing obvious that sticks out on the surface to say, this is where the glacier goes afloat. To find the hidden grounding lines, they examined radar images of the glaciers made by the European Space Agency's Earth remote sensing satellites from 1992 to 2011. Glaciers flex in response to tides. By analyzing the flexing motions, they were able to trace the grounding lines. This led to a key discovery. In all the glaciers they studied, grounding lines were rapidly retreating away from the sea. In this sector, we are seeing retreat rates that we don't see anywhere else on Earth, Rignot says. Smith Glacier's line moved the fastest, retreating 22 miles upstream. The other lines retreated from 6 to 19 miles. As the glaciers melt and lose weight, they float off the land where they used to sit. Water gets underneath the glacier and pushes the grounding line inland. This, in turn, reduces friction between the glacier and its bed. The glacier speeds up, stretches out, and thins, which drives the grounding line to retreat farther inland. This is a positive feedback loop that leads to out-of-control melting. The only natural factor that can slow or stop this process is a pinning point in the bedrock, a bump or projection that snags the glacier from underneath and keeps it from sliding toward the sea. To investigate this possibility, the researchers made a novel map of the bed beneath the glaciers using radar and other data from satellites and NASA's Airborne Ice Bridge mission. The map revealed that the glaciers had already floated off many of their small pinning points. In short, there seems to be no turning back.
Vast Southern Ocean. Further inland, the glaciers widen into a 2-mile thick reserve of ice covering an area the size of Texas. There's no doubt this ice will melt as the world warms. The vital question is when. The article then notes how Thwaites has been dubbed the Doomsday Glacier, and together with Pine Island Glacier, both could contribute 11 feet of sea level rise. Multiple meters difference in sea level height will OFC make a profound impact on every coastal city in the world. Hence, the question about how fast these glaciers will collapse is one of the most important scientific questions. The bad news, Holthaus asks? There's growing evidence that the Pine Island Bay glaciers collapsed rapidly 11,000 years ago, when global temperatures were similar to today, flooding the world's coastlines, partially the result of something called marine ice cliff instability. The ocean floor gets deeper toward the center of this part of Antarctica, so each new iceberg that breaks away exposes taller cliffs. Ice gets so heavy that these taller cliffs can't support their own weight. Once they start to crumble, the destruction would be unstoppable. In the past few years, scientists have identified marine ice cliff instabilities will flood coastal cities. Holthaus begins, in a remote region of Antarctica known as Pine Island Bay, 2,500 miles from the tip of South America, 2 glaciers hold human civilization hostage. Stretching across a frozen plain more than 150 miles long, these glaciers, named Pine Island and Thwaites, have marched steadily for millennia toward the Amundsen Sea, part of the Ice Apocalypse is the title of a new article written by meteorologist Eric Holthaus, contributing writer at Grist, published November 21, 2017. The basic premise: rapid collapse of Antarctic glaciers